Hey Math 1 students, so this video is for you to watch if you have been struggling a little bit with the 4.6 information, or if you just kind of need a little bit of a refresher before you take your test. So this is part of the 4.6 task, and specifically it's pages 17 and 18 in your pink packets. So Elvira, the cafeteria manager, has to be careful with her spending and manages the cafeteria so that they can serve the best food at the lowest cost. To do this, Elvira keeps good records and analyzes all of her budgets. So we're going to be looking at specifically the milk cartons. So the milk supplier charges 35 cents per carton of milk. So that is important. The milk supplier charges 35 cents per carton of milk. That word per immediately tells us that this is a rate. So let's see, we charge 35 cents per carton of milk in addition to a delivery charge of $75. So we're charged 35 cents per carton of milk, but we've also got this delivery charge of $75. The question says, what is the maximum number of milk cartons? So the maximum number of milk cartons that Elvira can buy if she has budgeted $500 for milk. So there's four different things that I've underlined here. I underlined a rate, and I know it's a rate because it's 35 cents per carton of milk. I underlined this $75 delivery charge because that's also something we have to pay. I underlined what is the maximum number of milk cartons. The reason I underlined that is because that's the question that we're truly getting at. That part actually tells us what our variable is going to be. Remember, when you read the question, it's always going to ask you a specific question, and it's going to give you your variable then, because that's the unknown. That's the thing that you're solving for. Now it says that Elvira has budgeted $500 for milk. So the thing we have to remember about a budget is we can spend that much money, but we can't go over that, which means we can spend $500 or less than that, which means if I've budgeted for $500, I need to spend less than or equal to $500. So I need to look at how much money Elvira is spending on the milk, and whatever she's spending needs to come out to less than or equal to 500. Okay? So let's see. We said that our variable has to do with the number of milk cartons. So how about we just do N? So N is the number of milk cartons. And now we need to write an inequality. So we said it has something to do with the amount of money she spends being less than or equal to $500. So if we think about how much money she's spending, she has to spend $75 for the delivery fee. She also has to spend 35 cents, so we're going to add 35 cents per milk carton. So since that 35 cents is our rate, we know that the variable is going to go right next to that. So there's our rate times our variable. 75 plus 0.35n is actually going to give us the total amount of money that Elvira is spending on milk cartons. And we know that that needs to be less than or equal to 500. So again, this 75 was the one-time delivery charge. The 0.35 is our rate. That's our amount per milk carton. And N is our number of milk cartons that we order. So now we have to solve the inequality and write the answer as an inequality and using interval notation. So we've got 75 plus 0.35n is less than or equal to 500. So we need to solve for that n right there. We're going to subtract 75 from both sides first. So 0.35n is less than or equal to 425. And then we're going to divide by 0.35 on both sides. Since we're dividing by a positive number, we don't have to worry about flipping our inequality symbol. And then we've got 425 divided by 0.35. So 1,214.29. 1,214.29. All right, so our solution is that n is less than or equal to 1,214.29. And now we're going to write that using interval notation. If we want to be less than or equal to this 1214, then that means we want all the numbers that are smaller than that. So our interval is going to start at negative infinity, and it's going to end at 1,214.29. And since we can equal that, we're going to go ahead and put a bracket to show that the circle would be closed if we were graphing it. Now we get to the real problem here. We have to look back at the context and figure out what this answer actually means. We have to remember that the question was, what is the maximum number of milk cartons that Elvira can buy if she's budgeted this $500? Well, this doesn't truly give me an answer. I don't really know what that means. So we have to think about how many milk cartons can she actually buy then. So if we want n to be less than or equal to 1,214.29, well, we can't have 0.29 of a milk carton anyway. So we're definitely just at 1,214. So the maximum number of milk cartons Elvira can buy, oops, spelled buy wrong buy. The maximum number of milk cartons Elvira can buy is 1,214. Now, we do have to talk about the fact that it really can't go to negative infinity either. So another way that we can write this is she can buy between 0 and 1,214 milk cartons. All right, so the big part here is being able to read the problem and understand where's your rate. Do you have a starting amount, or in this case a flat fee, a flat delivery charge? What's your variable? And where is your inequality coming into play? Once we write the inequality, the solving it and stuff should be the review part, and then the interpreting it and being able to write this sentence here is the other difficult part. All right, so we're going to skip part D there. We're going to go ahead and go to page 18 and do the next problem, and just a couple parts of it, just to make sure that you guys are understanding what we're going through here. So students love to put ranch dressing on everything, so Elvira needs to keep plenty in stock. The students eat, the students eat about 2.25 gallons of ranch each day. Elvira started the school year with 130 gallons of ranch dressing. She needs to have at least 20 gallons left when she reorders to have enough in stock until the new order comes. For how many days will her ranch dressing supply last before she needs to reorder? So if you notice, while I was reading, I was underlining some important things there. And I tried to keep my colors the same as I did on the last problem, so hopefully that worked. So the first thing I underlined was this 2.25 gallons of ranch each day. That word each jumps out at me. So the reason that that's important is because this is going to be my rate. Now the thing we have to be careful of is the students are eating 2.25 gallons of ranch each day, which means this rate that we're looking at needs to be negative. So it's going to be negative 2.25 for our rate because we're taking away the ranch dressing. The students are eating it. Okay. The next thing that I underlined was that she started with 130 gallons of ranch. So that's our starting amount. When I talked about over here subtracting this 2.25, we're going to be subtracting it from 130. I started with 130 gallons. I'm taking away 2.25 each day. All right. let's see what's next. She needs to have at least 20 gallons left when she reorders. So hopefully you guys are getting to be pros at what the words at least mean. If I need to have at least 20 gallons left, it means I need to have 20 or more. So that means it's going to be greater than or equal to 20 gallons. If I have less than 20, that's going to be a problem. But I can equal 20 and I can be bigger than 20. And then the last thing I underlined was how many days. That's going to give me my variable. So in this case, I'm going to go ahead and say D is going to equal the number of days. And now I'm going to write my inequality. So remember, I was talking about how we started off with 130 gallons of ranch dressing. Students are going to eat, so take away, 2.25 gallons of ranch each day. That's where our variable comes in. So this expression here, without anything else, is going to tell me how much ranch dressing Elvira has left. She started with 130. We're subtracting 2.25 each day. So then we need to have at least 20 gallons left. So that's our greater than or equal to 20. So part B says Elvira believes that she can make the ranch dressing last for 49 days before reordering. Is she correct? Justify your reasoning. So in this case, we already have an inequality. We're saying that 130 minus 2.25D has to be greater than or equal to 20. Well, she's guessing that it'll last for 49 days, which means D is going to equal 49. All we have to do to figure out if she's right or not is see if 49 is a solution to this inequality. So I'm going to go ahead and take out the D and plug in 49 and see if it actually works. See if it becomes a solution to this inequality. So I always like to put a question mark here, so I'm showing, is this actually true? So if we go ahead and put that into our calculators, let's see. We're going to do 130 minus 2.25 times 49. And we get an answer of 19.75. So 19.75, we want to know, is that greater than or equal to 20? And hopefully right away you guys can tell me that no, that's not true. Which means Elvira's wrong. This is not going to last 49 days because on day 49 she's only going to have 19.75 gallons left. That's not going to then last her until her supply gets in. So we have to first say that no, Elvira is incorrect. After 49 days, she will only have 19.75 gallons of ranch left, which is less than 20. So we have to acknowledge that no, she's wrong, and then we have to be able to explain why. And the reason why is because after 49 days, we got to this 19.75, which means she's not going to have at least 20 gallons left. That's going to be a problem. All right, so now we're going to go ahead and solve our inequality and figure out what our solution is then. So the first thing we're going to do is subtract 130 from both sides. So we get negative 2.25D is greater than or equal to negative 110. Now we're going to divide both sides by negative 2.25. So we've got D, and we have to be careful. We're dividing both sides by a negative number, so we need to flip our inequality. So D is going to be less than or equal to whatever number we get there. Let's see, negative 110 divided by negative, what was it, 2.25? So 48.89. So that is our inequality. That's the inequality portion of our solution. Now we need to go ahead and do the interval notation. So again, if we want D to be less than or equal to 48.89, this 48.89 is our maximum value. We want everything that's less than that. So our interval is going to start at negative infinity, and we're going to go up to 48.89, and we're going to include that, so we put a bracket. Now we have to look back at the context of the problem and describe what this actually means. So we have to remember that D stood for the number of days. So we're saying that D, or the number of days, has to be less than or equal to 48.89. Well, we can't have 48.89 days. So what that means then is the ranch will last for a maximum of 48 days. So I think the best way to word this, let's see, so Elvira will need to reorder on day 48 or before then. If she orders on day 48, she'll be able to make it until the ranch comes. If she orders after that, that's going to be a problem. So we have to make sure we're interpreting this the correct way, because sometimes we want to round this up to 49, but that wouldn't work, because if we go to 49 days, we said she's not going to have enough. So in this case, even though it seems weird, we almost have to cut off the decimal point, and we have to just care about the whole number here, because we need to be less than or equal to. All right, hopefully that helps clear up some of the stuff from 4.6. If you still have questions, please make sure you talk to your teacher. We've got our test coming up later this week.